All right, this is the third video of solving trig equations. And again, they just kind of progressively get a little bit harder. So we're looking at solving secant squared times tangent is equal to 2 times tangent. So most of these equations, if you have a square, it's like a quadratic-ish kind of feel. We want to bring everything over to one side. So if we do that, we would subtract this over equals 0. All right. So what we can do with this is they both have a tangent attached to them. We can factor that out. So tangent of theta, and then that's going to leave you secant squared theta minus 2 is equal to 0. And then just like any kind of a thing that you factor, we're going to set each factor equal to 0. So we got tangent equal to 0, secant squared theta minus 2 equal to 0. And this one, we just kind of have to logic our way through our answer on this one. But this is, we got to do a little bit of math on this one. So let's do our tangent, and then we'll go through the math on this. So tangent of theta equals 0. I like to make these into fractions just to kind of help our cause a little bit. So tangent is going to be an opposite over adjacent, but there's no triangle that has an opposite of 0, so we're thinking more of the fact that tangent is y over x. So we need a y value of 0 and an x value technically of anything. So we're looking at 90 degrees. Y value of 0. So we're looking at 0 degrees, 0 and pi is what we're looking at. So theta is going to be 0 and pi. So there's 2 of our answers. And then over here, we're going to get a whole different set of answers. And the fact we're going to square root, so we'll probably get a whole bunch of answers. But first thing is we'll bump the 2 over. So we have secant squared theta equals 2. I don't love dealing with secant at all. I'd much rather deal with cosine. So at this point, I'm going to do the reciprocal of secant, which means I have to do the reciprocal of 1/2. And then I can square root. So we're looking at cosine of theta equals plus or minus the square root of 1 is 1. Square root of 2 I can't do. Now normally I would rationalize, but this is not my final answer because this connects me to the appropriate triangle that has a 1 and a root 2 in it. So cosine of 45 is adjacent over hypotenuse. So we're looking at a whole bunch of 45s. In fact, we're looking at all the reference angles of 45s. So we're looking at pi over 4, 3 pi over 4. We're looking at 5 pi over 4 and 7 pi over 4. So this thing actually ends up having 6 different answers. The only thing that you have to take into consideration on this is the fact that tangent does have asymptotes. It's undefined at pi over 2's, so we couldn't get pi over 2's. And secant, if you remember your secant, secant is built off of cosine. So we'd have pi over 2, pi, 3 pi over 2. So these zeros for cosine become asymptotes for secant. So sometimes when you get, sines and cosines don't have a problem, but any of the cosecants, secants, tangents, cotangents, all have domain issues. And so just because they work for one piece of it doesn't mean it's not going to work for the other piece. So both tangents and secants both have domain issues at pi over 2's, and we don't have that. So we don't have anything related to that at all. So all 6 of these answers should be okay. But I would graph it just to make sure. I would go back and graph either this or this. If you're graphing the second equation, you're just looking at from 0 to 2 pi. we graph this equation and we're looking for where our x-intercepts are, and you should see 6 of them. So, and you can even put your scale appropriately in your calculator, and really it would be nice and kind of easy to see on that calculator. All right, let's do one more. So 9 sine squared theta minus 6 sine theta minus 1 equals 0. All right, so this is a very clean looking quadratic, but is it factorable? That's kind of the biggest thing. So turns out that it's not. So if it's not factorable, how do you deal with that? Well, you can do quadratic formula. But the difference is that it's not x here, it's sine of theta. So rather than x equaling, you're going to be doing sine of theta equaling, and then you do your quadratic formula. So you'd have a negative 6 plus or minus square root of negative 6 squared, 36 minus 4 times 9 times negative 1, all divided by 2 times 9, 18. So if you put all that into a calculator, you're going to get sine of theta is equal to 0.805 and negative 0.138. All right, so this is not coming from this, so it is turning into a calculator problem. Doesn't happen very often, but it definitely does happen, and it's just the fact that this just doesn't factor into any of these values that we're used to. So we're looking to solve two different things. So theta is, we are going to be plugging this into the calculator, 0.805, and we're going to be plugging in inverse sine of negative 0.138. All right, so if we plug that into a calculator, we're going to get out answer of 53.6 degrees. And over here, we're going to get an answer of negative, actually. We're going to get a negative angle out of this. So we're going to get a negative 7.9 degrees. All right, so here's our problem. Negative 7.9 is not in our range. So there's problem 1. Problem 2 is our original problem was not an inverse sine problem. So we have multiple answers. So this 53.6 degrees is actually, there's going to be 2. That's your reference angle. So it's 53.6 degrees. So you're looking at this quadrant of 53.6, and you're looking at this quadrant of 53.6 because sine's positive in these two. So that angle, so really we have theta is going to be 53.6 degrees, and then if you take 180 minus 53.6, you also get 126.4 degrees. So right here, if you did sine of 126.4 degrees, you would get that decimal right there. So you're going to get 2 answers from this one. You're also going to get 2 answers from this one, but it's not going to be that because we're not in the right range, but it helps us draw our picture. So we're at almost 8 degrees right here. I mean, that's probably quite a bit of an exaggeration, but so that's about 8 degrees. So we want all the way around, and then we want it over here as well. So this is 7.9, and this is 7.9. So if you take 360 minus 7.9, that's going to get you 352.1. And then here, if you take 180 and add 7.9, you're going to get 187.9. And you're going to get our all the way around to 352.1 degrees. So those are definitely trickier when you get something like that because they just kind of go out of our normal realm of comfort, and doesn't mean we can't do it. We just have to kind of think outside the box a little bit on that one. We're going to do one more problem, But it's going to be 100% calculator, meant to be calculator right from the very start, so we'll just do a part 4 on this one because the equation is so messed up looking that I don't even know where to go with it. And it's meant to be that way. So how do you deal with it? How do you use a calculator to really get an answer from something like that? And we'll do that on the next video.